Very excited to share today a brand new integration technique that I've developed called integration by smarts, which for those of you with upcoming exams, I think you should be bearing in mind for those exams because it's very powerful. So okay, we've got the integral of x to the 4 to do. This is a very difficult integral, so what we're going to do is we're going to split it into x to the 2 times x to the 2. And now, of course, we've got two functions here, so we can apply integration by parts. Now, I'm going to do this shorthand because I can't be bothered to do it the longhand way. Just choose the function you want to integrate. So this one can become x cubed over 3, and just write that down a couple of times. And then pick the other one and just leave it alone the first time, and then differentiate it the second time. You get this, and then slam in a minus integral sign in the middle, and you're done. Now, these two terms come together really nicely, so that's fine. Now, what about this over here? Well, unfortunately, that requires another integral by parts, I think. So get out some big brackets and then integrate this one to make x to the 4 over 12. Do that a couple of times. Leave this one alone here, and then differentiate it here, and then take away the integral in the middle. And I think we're getting closer to an answer now, because this just collects together. That's nice. 2 over 12 is a sixth, and that's just a constant, so I'll bring it out to the front. And what's really nice about this is that if you define your original integral to just be I, then therefore this is, of course, still I. And this thing here is just I. So we end up with I equals all of this plus a sixth I. And we can take away a sixth I from both sides. We can collect together these two things here. We can cancel the sixes. We can divide by 5. And of course, do not forget, you've done some integration, so do not forget your minus c, which we always write. And then, of course, at the end of all this, you just sign off with a integration by smarts. Because you've got to explain to the examiner how you managed to do a question this difficult. And unless you write this, they're not going to understand what it is. And maybe they can Google this and they'll find this video and that will help them with their understanding of the concept. Another way you could apply this, though, is if you're doing an integral like this. So integral of sine squared, well, again, let's just write this as integral of sine sine. Now we can integrate one of these a couple of times. Let's integrate this one to be a minus cos and write that one a couple of times. And now leave this one alone. And then the derivative of this one is cos, so that goes there. And then slam in a minus integral sign in the middle. So that's good. These two minuses cancel. That's cos squared. So that's cool. Cos squared is 1 minus sine squared. So that's excellent. We can split this integral up here and here because we're just adding things in integrals. So that's fine. But integral of sine squared, again, if this is just the integral, then we can just say I is equal to that, which means I is equal to this. And that's I as well. So we end up with this here. That's fantastic. Integral of 1 is just x. Amazing. Add I to both sides. Divide by 2. And of course, don't forget your minus c. And sign off with the integration by smarts, because that's what you did. One last one, though, is what if you have one which you actually legitimately should be doing integral by parts on? Of course, here, what we should be doing is integrating this one and then differentiating this one, because, of course, if you differentiate this, you get 1 over x, and that cancels, and it's already nice. But, of course, that's not what we're going to do, because we all know that the integral of log x is x ln x minus x. So excellent. Let's just do that a couple of times. Keep this one the same here, and differentiate it here. Slam a minus integral in the middle, and that's our parts done. This looks really nice now, though, because we expand this out to get this. We can break this integral up here. Of course, minus minus becomes a plus. The 3 can just chill outside of here. This is just the original integral if you define it as I. One last time, so I is equal to all of this minus 3 lots of I plus 3 lots of this integral here. And of course, to do this integral, this is quite a difficult integral, so you're going to need to apply integration by smarts again. And I won't bother to type it all up, but if you do that, maybe break it up into x to the 2 times x to the 1, apply integration by smarts, because of course that's the only way to do this. You'll eventually get to this. It will take a little bit of time. You can also add 3i to both sides, and then you can divide everything by 4. And of course, well, bring those together as well, I guess. Then divide everything by 4. Don't forget the minus c. And of course, you did that via integration by smarts. Thank you for watching. Do use that in your exams, because I think it'll be really helpful and powerful to you.